Welcome to next in the series of videos on electromagnetic induction. In this video we're going to talk about one of the applications of Faraday's law, which is generator. So let's look at the construction of a generator. So you have exactly like a DC motor, you have two magnets, and these magnets are giving a uniform magnetic field. So let's say those magnetic fields are in this direction, and in the center you have what we call as a armature coils around the armature. So this is like this. These are coils, and in the center is your armature. So this is your armature, right? So armature coil, armature, and then you have this slip rings, two slip rings. This is to tap the output, and these are the outputs that you would tap, and in the output you would get an output which is an AC, which is in the form of an AC. And what you have here is here you can have a handle, or you can have something that is connected to turbine. So it can be a hydroelectric station or a steam turbines, steam engine, steam based or coal based system. So the turbines run the generator. Now what happens is you have by the way, I missed out on one of the labels here. So these are your brushes. So these are called the brushes, which connect to the rotating or touch the rotating part, right? And of course your armature is a soft iron core. So the objective of your armature is to increase the strength of the magnetic field by many folds, or the magnetic lines which are linked to the armature coil. It increases that strength by many fold. Okay, so now you have this is your view of the generator. So let's assume that your generator is this is a coil, and you have here A, B, C, D, and you're rotating this like this. So at the next moment you have your A, which is moved back, so this becomes your A, this becomes your B and C and your D, and after that the position of A, B, C, D changes. So A moves here, and then you have B and C and D, and again you have a rotation. You have A coming to the front, B, C, D, and finally you have the initial position, which is A, B, C, and D. So as you can see, as this coil is rotating, here the flux lines linked would be increasing, because there's more open phase through which the flux lines can go through, and then here the area it's almost in line with the flux lines. So there's almost no flux line that passes through the area, because there is no perpendicular. You need something to be perpendicular to the flux lines, like this, for maximum flux lines to pass. But if this is your flux lines and this is the face, so there's almost no flux line passing through the face. So that's the situation here. There's no flux line passing through, so your amount of flux is actually decreasing here, and then again you're opening up your face, so amount of flux is increasing, and similarly, you know, your amount of flux line is decreasing. So what that means is, to counter this, you have current produced such that these effects are is countered. So in the phase 1, so you have current which is being produced, and as the flux lines are reduced, you have the current which is coming down, and then you have, or maybe let's say it could be the other way around. You know, to counter that increasing flux, you produce current in the opposite direction, and then as this flux lines are decreasing, the current is increasing in this direction, and here, you know, the current is increasing again, and then current is decreasing at that final point. So this will be your output. So it's enough if you develop an intuitive understanding. You don't need to be accurate in this, but just an idea that what you get is an AC current would do. So this is how AC current is. In contrast, if it's a DC supply from a battery, your voltage would be constant, right? Your voltage and current would be constant, and here your EMF is cyclic. Now, why do you want to have AC over DC? Why is it preferred? So let's see that. So what are the advantages of AC over DC supply? In fact, the first electric current supply, you know, in the Niagara Falls was done by Edison, and it was a DC supply in the local area, right? It was Nikola Tesla who developed the first AC generators and checked the viability of transmitting AC current. Of course, AC had a lot of disadvantages. So if you compare the cost of AC is far lesser when you compare with DC. So the cost is high, and this has to do with the transmission loss. You know, we will see that a little in the following chapters. The transmission loss is pretty less because in AC we produce low current but high voltage, and you know that the loss is nothing but I squared R using wire. You know, when you transmit using wire, this is your loss. So your I is small means your loss is also less. And here the transmission loss is pretty high. The next one is your efficiency. The efficiency of AC generator is quite high, and DC for using a battery, etc., is quite less. And changing voltage, etc., changing voltage, this is easy. We use transformers, and here it's complex. You need complex circuits. So these are the key advantages of AC over DC. Now we can also contrast the construction of AC generator versus DC motor. Now technically the only key difference is, first of all, let's say, let's not just worry about the construction, let's worry about the difference between AC generator and DC motor. Let's look at them. So first is the principle. See, the principle of a generator is EMI, electromagnetic induction. Of a motor is force experienced by current carrying conductor in magnetic field. So that is a main principle. So there's a force that a current carrying conductor experiences. From construction point of view, there is not much difference There are more commonalities than differences, but the major difference is you have slip rings, and which is coaxial. We say that's coaxial, and here you have split slip rings. Now the idea is that you have in a coaxial you have slip rings like this, and in DC, to ensure that current is always in unidirectional, so these are your split slip rings. So these are your split slip rings. So that is a key difference from construction point of view. And finally, from energy consideration, here you have in a generator, your mechanical energy is converted into electrical energy, and from motor point of view, your electrical energy is converted to mechanical energy. So that kind of ends all that you need to know for AC generators. I hope you enjoyed this video. See you in the next one.